So we're going to do lattice enthalpy. Let's begin. Right, okay, so lattice enthalpy is the effect of ionic size and charge on the enthalpy changes of lattice enthalpy and hydration. So basically, what we're going to do inside this one is going to tell how does the ionic size and how does the charge affect these two different values, okay? So that's going to be based upon the fact that we have got lattice enthalpy that accompanies the formation of 1 mole of an ionic lattice from its gaseous ions. And so this is our lattice enthalpy here, gaseous ions creating 1 mole of an ionic lattice. We're forming a bond, therefore energy is given out, and therefore we have an exothermic process. Okay, and all of these processes we're going to refer to as either endothermic or exothermic, and if something gets more negative, as in it gets a larger negative number, and wrong term there, more negative number, okay, because it's a lower number, isn't it? If it gets more negative, it's a lower number. Okay, so that's why you've got to be really careful about all of this. All right, if this number is getting more negative, okay, you call it a more exothermic. So it's more exothermic. If it gets more positive, you're going to say it's more endothermic. Okay, so really important. We're going to use that all the way through. Move that to the side. Just remind ourselves about ionic lattices and why they do what they do, why they've got high melting points and boiling points. That's because all of the bonds between the ions are in all different directions. Okay, and the lattice enthalpy is based basically on how strong the bond is. So what affects the strength? Well, first of all, it's an exothermic change, and it's whether if it's a stronger bond, the more exothermic it is. So more exothermic. Right, so an exothermic change has a negative sign. Energy is given out when the bonds form. Makes sense, okay? The stronger the bond, the more exothermic it is. Now, why is that? Now, look at this third point here. The bond dissociation enthalpy, breaking them apart, which is the opposite of this down here, it's going that way, okay, will just be plus 711 or plus 711. So basically that means that it takes 711 kilojoules per mole to break this ionic lattice apart. And therefore the same amount of energy is given out when we make it. So that basically means if we get a stronger bond between this, it'll take more energy to break it. Let's just say we made that was a stronger bond here and it was over 1,000 kilojoules per mole to break it going that way. That means it's going to be more exothermic in the other direction. It'll be negative 1,000, for example. Okay, so the stronger the bond, the more exothermic the lattice enthalpy is because you're forming bonds and they're stronger. Now, why do these bonds get stronger? Okay, now it's to do with the ionic size. So here's an example here of sodium chloride. Now in the exam, you're going to get the same metal and then they'll change the non-metal, or you'll get the same non-metal and they'll change the metal. So what do you have to say in the exam itself? What you have to say is it's all to do with the ionic size. Okay, so the smaller the ionic size, look, my face can go inside sodium. Okay, so the smaller ionic size, the closer the two ions can get to each other. Okay, and if they can get closer to each other, those ions, those charges on the ions can get close to each other, so stronger attraction. Okay, so this is going to have a stronger ionic bond than that because the fluoride is a smaller ionic size than the chloride. Okay, let's move that to the side and see how this actually affects. So ionic size, really, really important, and that means your lattice enthalpy is going to become more exothermic if the ion is smaller. And let's have a look at this one. So we've got sodium chloride, lattice enthalpy is 787. Then we go to sodium bromide. We've changed the non-metal. Okay, it's got bigger. So if that's the case, is it going to be more exothermic or is it going to be more endothermic? Where is that number going to change? Well, the bond is going to become weaker. So the bond is weaker because the ionic size is larger. They're the two things you need to say. And therefore, the number is going from minus 787 to minus 751. That means that number is becoming less exothermic and more endothermic. So I'm going to describe this as getting more endothermic. We then go for iodide, and again, it's more endothermic, okay? And that is generally your trend. The ionic size is increasing of those non-metals, Remember, this can be the other way around with the metals changing as well. Strength of the ionic bond is decreasing. Lattice enthalpy becomes less exothermic, or you can say more endothermic. And these green things are the things you have to say in the exam, okay? So you have to say these in the exam. It's all about size and how that affects the lattice enthalpy, okay? And that's how you do it. So, charge and lattice enthalpy, how does that affect the lattice enthalpy? Well, it's the same thing as the previous. If you increase the charge, you're usually going to decrease the ionic size. So we've decreased the ionic size because the charge is going up, but also the charge is higher, so therefore higher attraction to the ions. So the charge is increasing and the ionic size is decreasing, which means you get increased attraction from the nucleus to the electron shell, because that comes in, okay, and the ionic size is decreasing. Right, and that means the strength of the ionic bond is increasing, whatever these lot bond with. And that means the lattice enthalpy becomes more exothermic. Okay, so anything that's bonded with these, let's just say we kept the non-metal the same, we said it was a chloride, 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 that lattice enthalpy would become more exothermic to do with these ions as you go across these three ions, for example, sodium chloride, magnesium chloride, aluminium chloride. Okay, so the next one we're going to do is enthalpy change of hydration. So enthalpy change of hydration is exactly the same thing. The size of the enthalpy change of hydration depends on the size of the ion. The smaller the ion, the more exothermic. Okay? Because it's forming a bond. It's forming a bond. Because it's forming that bond, okay, you can make a stronger bond because the ion is smaller, and therefore more exothermic change if you have an ion that's smaller. So charge and therefore the size of the ion across the period. So if we look at this, we want to talk about hydration enthalpies there. Minus 406, minus, notice it's getting more exothermic, okay, because the ion is getting smaller, okay, and therefore the bonds within the attraction to the water when you're hydrating it is getting stronger. And if there's a stronger attraction between the water and the ions, the opposite is true when you make the bonds, you give more energy out. It becomes more exothermic. Now, all we have to say in the exam, charge increase, radius decreases. Okay, and then say it's more exothermic, the enthalpy change of hydration. So it's quite simple, I hope. Size of the ion going down the group. Let's have a look at the ions down the group. As you go, the ion is increasing as you go down the group. So therefore, what's going to happen to our hydration of chloride versus bromide? Well, that means you're going to get a weaker bond because it's a larger atomic radius. If you get a weaker bond because it's a larger atomic radius, okay, that's going to become less exothermic or more endothermic. Okay, and notice the number there. So it's becoming more endothermic and less exothermic. It's less negative, it's becoming more positive, so more endothermic. And I can't emphasize enough, don't try and say it's getting larger, smaller, more negative, less negative. Just say more endo or more exo, or less endo. Okay, get used to doing that, okay? So the radius increases, delta H height is therefore less exothermic. Okay, so in this video we have, let's try and weave our way inside of these, okay? We have covered all of the enthalpy change of hydration. We have come in dancing like an Egyptian. And we are basically, have gone over all these answers now. What you need to do now is just get used to questions. So questions are just basically changing the metal, changing the non-metal, and asking you what the effect is. Now, there are 3 points on every single question on these things, and the 3 point is got to do with the charge or the radius or both, and whether it's exothermic or exothermic. And sometimes if you want to add to it, you can say the strength of the bond increases. That can help as well. Well, I hope this works. Remember, share, like, subscribe. I really, really appreciate it. Thank you.